Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0341, indicates an issue with the Camshaft Position, CMP sensor A, and the Crankshaft Position, CKP sensor. These sensors are critical components in the engine management system, responsible for monitoring the positions of the camshaft and crankshaft. The data they provide is crucial for the Engine Control Module, ECM, to optimize timing and fuel injection. If the phase between the signals of these two sensors is incorrect, it can lead to poor engine performance, stalling, or no-start conditions. This issue may arise from electrical faults, mechanical malfunctions, or wear over time. Diagnosing this code involves a systematic approach to identify and rectify any underlying problems proactively. The CMP sensor A is typically located near the top of the engine, often on the valve cover or camshaft. Its role is to monitor the position of the camshaft, which is vital for determining the optimal timing for fuel injection and ignition. The CKP sensor, usually found near the crankshaft, measures the crankshaft's position and rotational speed. Both of these sensors work in harmony to ensure the engine operates smoothly. Incorrect phase detection between these sensors can disrupt fuel delivery and deter optimal engine efficiency. Hence, understanding their locations helps in addressing associated DTCs effectively. The possible causes of DTC P0341 can include a range of electrical faults, such as short circuits or misrouted wiring, that hinder sensor signals from properly transmitting to the ECM. Mechanical failures, including a damaged camshaft or crankshaft, may also contribute to phase detection issues. Moreover, poor connections or loose terminals at both the variable timing control (VTC) oil control solenoid valve and the engine control module / powertrain control module (ECM/PCM) can disrupt communication. Identifying these causes early can prevent more severe engine issues down the road. Symptoms associated with DTC P0341 may manifest as rough engine idling, when the engine doesn't maintain a stable RPM level due to incorrect timing. You may also experience poor acceleration during driving, making the vehicle less responsive. Additionally, the vehicle might stall unexpectedly while running, leading to potentially dangerous situations on the road. If these symptoms are observed, it is crucial to address the issue as soon as possible to prevent further complications and ensure safe driving conditions. The first troubleshooting step involves turning the ignition switch to the on position, specifically to the 2 setting. At this stage, it's crucial to record all freeze data, which captures the vehicle's status at the time the DTC was triggered. Additionally, checking any onboard snapshots can provide insight into various engine parameters and conditions. Gathering this data serves as a foundation for subsequent troubleshooting steps, allowing you to effectively understand and analyze the context of the DTC. After recording the necessary data, proceed to clear the DTC using the Honda Diagnostic System, HDS. This diagnostic tool aids in erasing codes and resetting the engine's monitoring systems. Clearing the DTC allows you to conduct a clean slate test during the road test phase. This step is essential for identifying if the DTC reoccurs under normal operating conditions. Having the HDS at hand will streamline this process and make it much more efficient. Next, you will need to test drive the vehicle at a consistent speed between 19 and 38 miles per hour, 30 to 60 kilometers per hour. This steady speed is crucial for replicating normal driving conditions and allows for precise monitoring of the engine's performance. It is important to maintain this speed for a duration of 10 minutes. Document any anomalies that occur during this period. Proper observations during this step can reveal potential problems that may not have been evident while stationary. After completing the test drive, the next step is to check for any pending or confirmed DTCs using the HDS. Pending DTCs are codes that could be in the process of being triggered, while confirmed DTCs indicate an ongoing issue. If DTC P0341 is indicated, you should follow the troubleshooting path outlined in Step 9. On the other hand, if it is not indicated, proceed to Step 5 for further diagnosis. The results from this step dictate the next necessary actions to take. In this step, you will conduct the Variable Timing Control (VTC) test via the HDS's inspection menu. This diagnostic procedure is crucial to assess whether the VTC system is functioning correctly. After executing the test, evaluate the results thoroughly. If the result indicates OK, you can move on to Step 6. However, if the outcome is unfavorable, follow the procedure outlined in Step 9, which focuses on further investigation into the root causes of the problem. This systematic approach is essential for ensuring thorough diagnostics and repair. Again, perform another test drive following the same parameters as before, maintaining a steady speed of 19 to 38 miles per hour for 10 minutes. This repeat testing is critical to confirm if the parameters have changed since the last assessment. The primary goal is to check for any variations in performance or DTC appearance after making adjustments in the previous steps. Take note of any abnormal engine behaviors during this repeated drive to provide valuable insight into the diagnosis. Following the test drive, you should check the VTC status in the data list using the HDS. A vital part of this step is to determine if the VTC status is indicated as on. The VTC system plays a significant role in managing variable timing for optimizing engine performance. If the status is on, proceed to Step 8 for a more in-depth evaluation. Alternatively, if it indicates off, return to Step 6 for another test drive to ensure accurate readings. This back-and-forth process aids in refining the diagnostics. In this troubleshooting step, you will monitor the onboard diagnostics OBD status for DTC P0341 in the DTCs menu through the HDS. What you are specifically looking for is a failed indication, which would suggest that the system has not succeeded in resolving the issue. If the HDS indicates that the test has failed, you should continue with Step 9 to carry out further diagnostics. However, if it indicates passed or reflects an intermittent failure, it suggests that the system may be operating correctly at that moment. Ensure to check for any poor connections or loose terminals at the VTC oil control solenoid valve and the ECM PCM. To initiate Step 9, turn the ignition switch to the lock position, labeled as 0. This is a preparatory step before testing specific components in relation to the DTC. Once the ignition is locked, you will begin testing the VTC oil control solenoid valve. Assess whether this component is functioning properly. If your testing indicates that it is in good condition, you can proceed to Step 11. If it is found to be defective, replace the VTC oil control solenoid valve and then follow Step 14 for subsequent procedures. This step focuses specifically on testing the VTC oil control solenoid valve, which is a crucial part of the VTC system. Its role involves regulating oil flow to adjust the camshaft timing, thus significantly influencing engine performance. By checking its function, you can determine if it is contributing to the problem indicated by DTC P0341. If the valve is functional, you move on to checking the camshaft timing. If it's not working as intended, you need to replace it and then follow Step 14 for the subsequent actions. The next step involves checking the camshaft timing to ensure that it is within the manufacturer's specifications. Proper alignment of the camshaft is critical, as it directly affects the synchronization between the crankshaft and camshaft. If the camshaft timing is found to be off, corrective action involves resetting the camshaft timing. If everything is found to be within acceptable limits, you can proceed to step 12 for the next phase of troubleshooting. Keeping the timing right is essential for optimal engine performance and trouble-free operation. At this stage, it is vital to inspect the cam chain for any damage or stretch. The cam chain's integrity is essential for maintaining synchronous operation between the crankshaft and camshaft. If there is visible damage, or if the chain has stretched beyond its expected limits, it compromises the timing chain's ability to function properly. In this case, it is advisable to replace both the cam chain and the auto tensioner to ensure reliable engine performance. If the cam chain appears to be fine, proceed to step 13 for further diagnostic actions. The focus now shifts to inspecting the variable timing control (VTC) actuator. The actuator is responsible for adjusting the camshaft timing based on the engine's operational conditions. Accurate functioning of this component is crucial for effective variable valve timing. Inspect the actuator for any signs of wear or malfunction. If it is deemed to be functional, proceed to step 14 to conclude the troubleshooting process. Conversely, if it is found defective, replace the VTC actuator and then continue to step 14. In the final troubleshooting step, turn the ignition switch back to the on position, specifically to setting 2. Following this, it's essential to reset the engine control module, powertrain control module, ECM, PCM, using the HDS to refresh the system and apply your previous repairs. This action ensures that any previous DTCs are cleared from the memory and sets the stage for normal system operation. It is a significant step to restore the engine's performance post-diagnostics, as it allows for a fresh start. After completing this step, a final test drive may be advisable to ensure that all systems are functioning as expected. The final repair verification process involves rechecking the DTC with the HDS to confirm that DTC P0341 has been successfully resolved. During this phase, it's important to monitor the engine's performance, including factors such as idling stability, acceleration response, and overall functionality. These parameters will indicate whether the repairs made have effectively addressed the underlying issues. If no new DTCs appear and performance is satisfactory, you can conclude that the repairs have been successful. This step is essential for ensuring that the vehicle is in optimal condition before returning it to the customer. Preventive maintenance is crucial for prolonging the lifespan of components like the CMP and CKP sensors. Regular inspections of these sensors as part of routine maintenance can catch potential problems before they escalate. Additionally, monitoring sensor performance can help identify issues with timing and engine response. Another important aspect is to check the wiring harnesses and connections, as wear and tear here can significantly impact sensor readings. By maintaining these systems, you can prevent the recurrence of DTC P0341 and ensure long-term reliability of the engine's performance. In conclusion, DTC P0341 points to an issue with the correlation between the CMP sensor A and CKP sensor, critical for smooth engine operation. Following the outlined troubleshooting steps methodically will help diagnose and rectify the issues effectively. Be vigilant in conducting regular inspections of these components as part of preventive maintenance to mitigate future occurrences. By taking these proactive measures, you maintain operational efficiency and enhance the longevity of the vehicle's engine system. Always ensure that the repairs made are verified and validated before concluding the service. Please like and subscribe to the channel. See you next time.